to our Knowledge Culture webinar.
That's a very good question. Definitely, yes.
Fun customer scenario questions, and I'm excited to discuss today.
Hello, and welcome to our Knowledge Culture webinar. Today, we'll be focusing on cell culture optimization, manufacturing, and the all-important security of supply. My name is Stephen Hume from Thermo Fisher Scientific, and I'll be your host. Before we look at the agenda today, then let me introduce you to our webinar console. So the navigation bar at the bottom of your screen has several options. If you click on any of these buttons, they open and close some of the windows that you have on your screen so that you can personalize the view you have of the webinar. So button number 1 is your media player. It allows you to see our presenters. Button number 2 is the live view of the slides. Button number 3 is because we'll be having a question and answer session at the end of the webinar. So that controls the Q&A box. As you're viewing the presentation, please put any questions you have for our presenters into the Q&A box. Now, button number 4 is the icon that looks like a question mark. That's in case you need any technical support today. So if anything isn't working for you, click here and we'll try to help. Of course, we're always interested to hear if you've enjoyed our Knowledge Culture webinars. So button number 5 is to access the survey. You can fill this in at any point of the webinar, or it'll be available at the very end as well. I'll remind you again later, but we'd be very grateful to hear your comments here. There's also a couple of links that we thought you might be interested in today, which can be open and closed using the green and the blue buttons. A media panel is a collection of diverse media or feed formulations that is used in media screening, and it can help identify the optimal media formulation for a clone that you're interested in. Completing a panel evaluation can give you multiple benefits: speed, diversity of formulation, scalability, and certainly if you use a GIBCO panel, access to a technical team that can work with you throughout the process. Ultimately, you're looking to help identify nutrients that increase titers and cell productivity, therefore saving you time and money. Once you've determined your media or feeds, deciding on a manufacturing partner has never been so critical. Strategic outsourcing can help you consistently fulfill your long-term requirements for global scale-up. Maximizing productivity while minimizing risk and maintaining compliance with critical safety measures is the target state. So during today's webinar, we'll be discussing best practices on how to achieve that end goal. And we'll also be looking at an area which has never been more important: Thermo Fisher Scientific's global media manufacturing capabilities, from rapid prototyping through to CGMP. With all of that in mind, here's what's on today's agenda. You'll first hear an overview of the key characteristics of a media panel, the benefits of using one, as well as considerations when setting up a panel evaluation. Maren Grun, Field Application Scientist from Thermo Fisher Scientific, will be talking us through that first section. We'll then welcome Leonardo Sibilio, Production Manager of Rayterra SRL, and he'll be joining the panel. Leonardo will be discussing his experience of best practices when completing a media panel evaluation. We'll then welcome Erika Wong of Thermo Fisher Scientific's Cell Culture Department. She's an R&D manager, and she'll be here to shed some light on a number of case studies around the evaluation of the CHO panel media and feed library. And our last presentation today will be from another one of my colleagues, Megan Gorsica. Megan is a senior product manager, and today she'll be looking at both manufacturing and security of supply. We'll end with our Q&A session, so make sure you put your burning questions into the Q&A box for our presenters to answer later. Let's find out a little bit more about Thermo Fisher Scientific before we move on to our presentations then. At a glance, we have 75,000 employees worldwide. Our employees are global thought leaders in all areas of science, and we are able to harness the power of that knowledge for you. Our customers are of the highest importance to us. We have 10,000 customer-facing employees, so we are always there for you. 5,000 of our employees are scientists or engineers themselves, so no matter what you specialise in, we have scientists in-house focusing on the same topics. We are, of course, committed to advancing science and innovating, which is why we invest $1 billion in R&D every year. Now, our mission is to make the world healthier, cleaner, and safer. At our core, we are scientists, and our purpose is to enable our customers to fulfill their scientific purpose. We provide our leading products, services, and workflow solutions through the 6 brands that I'm sure you'll recognise on this slide. And as represented here, the customer is at the heart of everything that we do, alongside our focus on innovation, productivity, and quality. Okay, time for our first speaker then. She's joining us from Switzerland today, providing an overview of media panel key characteristics and benefits, as well as considerations to be made when setting up a panel evaluation. Please welcome Maren Grun. Hi, Maren.
Thanks for the introduction, Stephen, and good afternoon, everyone. So as Stephen just said, for the beginning of today's webinar, I am going to provide you with an overview of the panel approach and panel evaluation, which can be a valuable tool during cell culture process development and related media optimization. And I would like to start doing so by answering the question how a panel approach can help you to reduce uncertainty. A media panel, again, is a collection of diverse basal media or feed formulations used during early process development for media screening to help identify optimal formulations for a targeted clone. There are some things needed for a panel evaluation. Firstly, the diversity of the tested formulations. But apart from that, there are also some other important factors, which would be the flexibility for you to complete the evaluation within your own lab according to your capacities and timelines, using an established protocol that can be fit to your process if needed. And lastly, also access to support from a technical team that can help with the experimental design, data analysis, and next step recommendations. Now, why would you want to screen a panel? It is known that every clone, even when derived from the same parental cell line, does have different nutritional needs. And optimizing media in order to meet those nutritional needs can lead to improved productivity and titers, saving both money and time. Having said this, screening a set of diverse formulations, such as the panel, can help to identify optimal formulations for a clone of interest to improve productivity and reduce timelines. Coming back to the question how a panel approach can help to reduce uncertainty, Panels can do so through the following three aspects. Firstly, the known nutritional diversity of the formulations that are ready to use, usually provided in liquid format for assessment in your early process development at small scale, and they can potentially lead to further formulation optimization. So altogether, really helping to identify an optimal clone-specific formulation. Now, I have been mentioning the formulation diversity already several times because this is really one of the key characteristics and benefits of a media panel. And I would like to provide some more detailed insight into the importance of diversity within the next couple of slides. The diversity of screen formulations is important because, as I mentioned before, there is a clonal and thus nutritional needs diversity. And what you can see here on this slide is that certain formulations like Formula 3 might be good for one clone and its nutritional needs, whilst other formulations may not be that appropriate. However, those other formulations may be just a perfect fit for other clones, so it is really important to expose your clone to an as diverse population of media as possible in order to find the right nutrient formulation to achieve high titers and high productivity. Meaning that the formulations tested should vary in the different main component levels, being either high, medium, or low, and also different main component level combinations. And we are actually going to share heat map examples of how such panels with high diversity can look like, or should look like, later on today. With that, the diversity is one of the three key benefits that a media panel can provide, especially since if the heat map of the panel is shared, this really allows you to get an understanding which components are driving the productivity and quality. The other two benefits of the panel are speed and diversity. So speed is given since the formulations can be accessed rapidly, providing the option to test beyond catalog offerings. And simplicity is given as the formulations come ready to use and with a clear and concise protocol. So when you're at the stage of setting up a media screening, you could either go with a diverse media library, such as a media panel, or you could choose to test existing catalog options. When comparing those two approaches, they are very similar in regards to timelines and budget. However, the nutritional profile of the formulation is where the difference does come in. So when screening a media library or a panel, you are provided with a set of formulations that has been put together because of their diversity. And as I said before, this is just what is allowing you to quickly narrow down on the right nutrient combinations for your clone. In contrast, when screening a set of existing catalog options, you usually have no or only very limited insight into the formulations. Thus, you might end up screening a set of formulations that is not truly diverse, and this might not allow you to find the right nutrient combination to increase titers to where they potentially could be. So to sum things up, a media panel can facilitate the identification and development of a custom clone-specific medium that is easily scalable, and it does come along with technical support. Having talked about the general media panel approach, let's have a look onto the media panel workflow and how to set up a respective experiment. Before actually starting the evaluations, you should identify the criteria that will set you up for the best success, starting with reviewing historical data and identifying the key performance indicators that you would need to monitor throughout the evaluation. Next to this, it is also important to identify process details and expectations, such as the scale for testing versus manufacturing scale, as well as the desired media format for manufacturing, which might be different from the one that you are using for testing at small scale. Or also, is there any feed or supplement timing known to be important to increase cell growth and productivity? Furthermore, you should also identify existing process pain points, like concerns with the final product quality, scalability issues, or any other process challenges that you are currently facing. And of course, it is also important to take project considerations such as timeline and budget into account. On this slide, I would like to show you the potential components of a media panel evaluation experiment. One of them, of course, being the media panel evaluation, where you would screen a set of diverse media to identify which of the formulation does provide the highest productivity and titers paired with high cell viability and growth. And it might very well be that at this stage you can already identify a final formulation which does provide you with the desired performance. But potentially you may want to perform spent media analysis to identify your clone's nutrient utilization, which then provides the opportunity to further optimize the formulation by aligning nutrient levels with the clone's nutrient utilization. And once a final basal medium is identified, there is then the option to screen a feed panel to further increase titers by fed batch mode and by finding a feed that is fitting best to your basal medium as well as your clone's nutritional needs. So really, when all of those factors are combined, that's when you get the full benefit and can see improved titers and quality as far as downstream goes. The next step, after identifying your success criteria and deciding on the components of your panel evaluation, is the experimental setup. And this is definitely simplified by the established protocol that I have been mentioning before. Nevertheless, as for any experiment, there are certain considerations that you need to make, and you should be aware of your cell's sensitivities as well as of the overall project goals. And some of the most frequent and important questions are whether your cells are dependent on any specialty components, such as insulin or growth factors. Are your cells prone to clumping or shearing? What scale will you be testing at? Or do you need to collect samples for future analytical needs, such as spent media analysis? To conclude this section, this slide shows an example of a basal media panel workflow. The evaluation will start with preparing the media and preparing the cells for seeding. So everything is ready for the cells to be adapted into each of the different media panel formulations before the actual growth performance assay can take place. And throughout this growth performance assay, you would then collect data on your key performance indicators that can then be compared to your historical data and can be used to identify elite formulations. And then from there, you may have a few potential next steps, including spent media analysis and fed batch or feed panel to test. Or you could require to have a media optimization project, which would be a bit more of a specific road to go down for you. And then lastly, you would have the option to either receive additional prototype material to test in your process development, or to go with GMP material when you are moving into manufacturing. And those options will be outlined in more detail later on. And having addressed all of those different options, I think it's important to mention again that we are able to help with analyzing the data and moreover determining the best path forward for your clone. And with that, I hope that this overview could provide you with a good understanding of the panel approach, and I would hand back over to Stephen.
Thank you, Maren. That was really interesting. And just a reminder, if you do have any questions for Maren, then please just put them in the Q&A box and we'll address them at the Q&A session at the end. We're going to stay with Maren for our next section of today's Knowledge Culture webinar. She's going to be in conversation with a gentleman that has been working in the biotech industry for 15 years. He has held several managerial positions from process development to GMP manufacturing, and he has a lot of experience around CHO-based processes for the production of mAbs and recombinant proteins. He has recently moved into the adenoviral vectors field, now the production manager of a commercial scale facility for Reterra SRL in Italy. Please welcome Leonardo Sibilio. Over to you, Maren and Leonardo.
Once again, thanks, Stephen, and also thanks, Leonardo, for joining today.
Thanks for having me.
Leonardo, as Stephen just introduced, you have a lot of experience with CHO-based processes and moreover with media development and optimization needed for those. So what would you say are the general options to find a new medium and or develop media platforms?
Well, I think that basically there are two options. First option is screening of existing catalog media or panel prototype media that can lead to find a good medium. And there is spent media analysis. You normally want to use spent media analysis when you need to develop a more specific, customized medium for your cell line or for your clone. For example, I made a lot of use of design of experiment to adjust existing formulation following a spent media analysis. Making tailored addition of amino acids or supplements, different concentration, or define fed-batch strategies can improve the performance of existing formulation. And also in some cases, what happens is that you have a process that is in an advanced clinical stage. But the process was developed very quickly, based on a platform medium, for example, during the early development phase. And this normally is because people want to go into clinical trial as fast as possible. But then you realize that productivity might be too low or yield could be improved. Plus, at this stage, you don't want to make many changes, but only minor clone-specific tweaks to your platform medium. And that's something where you can rely on spent media analysis, I think.
Okay, and when you talk of adjusting formulations by either DOE or minor adjustments, what kind of support did you receive from media suppliers, or what kind of support were you actually looking for?
Well, mainly we did evaluation and design of experiment by ourselves. But nonetheless, support from vendors is important because it is based on knowledge of the media formula, which normally the customers don't have. So some tricks can be helpful, and it is important to have a constant exchange of information from both sides.
I see. And yeah, I also think that it is important and it can be beneficial to collaborate during the development of a tailored medium.
Correct.
Now, we have been talking about the very general options for finding and potentially optimizing a media formulation. And as you have been addressing the spent media analytics, what kind of components were you looking for when doing the spent media analytics?
Well, right. We have made use of spent media analysis in the past and several experience with outsourcing services, including Thermo Fisher Scientific. And to my experience, that's where you get a clear picture of what is missing in the media, and you can make some optimization around soon after, initially in the AMBER 15 system, for example. In the past, we looked at all the components that could be analyzed, such standard main metabolites, amino acids, trace elements, soluble vitamins, lipids, etc. But what I've seen is that normally the most important factor is amino acids. For example, we have seen that some amino acids were missing, but also some vitamins were missing. Then we did some screening experiments to see if supplementing amino acids, vitamins, or a combination of amino acids and vitamins could enhance the process performance. And we realized that especially amino acids increased productivity, while vitamins played a minor role. So initially, I would focus on amino acid analysis.
Yeah, that actually goes in line with what we are doing for initial spent media analytics. So indeed, we are looking at the amino acids and water-soluble vitamins and adjustments of their concentrations in the medium or by feeding strategy can lead to increased titers. And though there might be cases where this actually does not lead to improved titers, I think it's still a good and straightforward approach for initial optimization.
Yeah.
Now, you actually have been screening our panel in the past, and there is a paper out there that we linked in the resource box for the people that are interested to have a look at that. What was the reason back then that you decided to test the media panel?
Well, that's an interesting question, though. Back we had a CHO, the G44 cell line, and a clone especially, for that process, which was particularly reluctant to adapt to different media. And moreover, we did not have much time to do the optimization. And so we decided to screen catalog media. But as I mentioned, this clone was particularly hard to adapt to any of the catalog media available on the market. So then we decided to move to a more precise spent media analysis. And we understood why cells adapted poorly. That the media was particularly poor of some amino acids, and the cells were particularly greedy of those amino acids. And that was something that was negatively impacting our process development.
And then when you moved into the panel formulations, were there actually some formulations that had those amino acids or that the cells could adapt to?
Yeah, correct. The first thing we did after spent media analysis, we wanted to test also this panel media. And we found that some formulations were really outstanding because we saw that sort of 4- to 5-fold increase in cell growth, which was something we have never seen before with that clone. Productivity was not as outstanding as growth, and probably because the project needed some further minor optimization. And indeed, the next step was testing the feeds panel in combination with the candidate media, and in order to find the optimum feed strategy.
Okay, and given your experience having performed both catalog and panel evaluations, what's your thought on, or could you recommend the panel? What's your thought on going with panel versus catalog for finding an ideal clone-specific medium?
Well, it much depends on the company and the capacities that can allocate and the resources as well. But if all of these are not limiting, I'd suggest to go with the panel evaluation because it is quicker. The other option is to improve the performance of your current media by screening supplements, feeds, or changing feed strategy. With this option, you would make only slight changes to your existing medium, which can be an advantage in some cases, but for sure it is more time-consuming as well.
Okay, well, thanks for sharing your thought on that. And I agree, it's always about weighing different factors and, kind of seeing which approach and choice might be best for a unique situation. And as you said, if it's about needing a less time-consuming tool, then the panel is definitely a great tool. So thanks a lot, Leonardo, for joining today and for sharing your experiences with media optimization.
My pleasure. Thank you.
Stephen, back to you.
Yes, thank you so much for joining us today, Leonardo. We really appreciate it, and it's great to hear your experiences. I'm sure there'll be plenty of questions coming in for you as well when we come to the Q&A. So a big thank you again to Maren and Leonardo. On to our next speaker then. She holds a master's in physiology from the University at Buffalo in the US. She has over 10 years experience with the custom service team and currently supports media development, cell line development, and panel offerings. Our next speaker is R&D manager within Gibco PD Express Services. Here's Erika Welling. Hi, Erika. Can you hear us, Erika? Erika, if you can't hear us, maybe just try refreshing your browser because we can't hear you. Tell you what, if let's try and fix some issues with getting Erika on the mic. Maybe you're muted, Erika. The biggest phrase of 2020, you're on mute. Could you be muted?
Can you hear me okay right now?
Yes, yes, we can. Lovely.
Okay, excellent. Awesome, thank you. Okay, hello. Thank you for the introduction, Stephen. Today I'll be presenting on 2 different case studies, with the first being the case study around the basal panel, and then the second case study around an evaluation of the feed panel. All right. So in the first case study evaluating the basal panel, this study used 3 diverse cell lines, each expressing a different molecule, evaluating 8 CHO panel basal media formulations in simple fed batch mode, meaning glucose fed only, with each cell line having a different control medium, which was tested alongside the panel media. And to prepare for the experiment, cells were thawed in the control medium, and after recovery, were directly adapted to the 8 different panel media for 4 passages prior to the growth performance assay. This evaluation was conducted 15 scale down model for 14 days. And before jumping into the data, I'd like to just point out that each panel comes with a protocol, consultation by FAS and R&D teams, as well as support with data analysis. And as you can see here by the heat map, the 9 formulations are quite diverse in composition, showing a range of component group concentrations relative to each other. Okay. And for this data set, you can see here that we're showing the 3 different cell lines, and we see a broad range of titer results for each of the 3 cell lines, demonstrating the importance of panel diversity. Out of the 8 basal panel media tested, the highest titer condition for cell line 1 was basal medium 3, and the cell line 2, for cell line 2, it was basal medium 4, and for 3, it was basal medium 6. So overall, the titers were improved up to 2 to 4.5 fold over the cell line specific control medium. When comparing volumetric titer improvement to specific productivity improvement over the control, you can see that the panel has a different effect for each cell line. Cell line 1 shows increases in titer through specific productivity, whereas cell line 2 shows increases in titer through growth. This shows that each cell line can respond differently and further emphasizes the need to test a diverse panel to suit the requirements of your cell line. So in the second case study, we evaluated the feed panel, and for this experiment, 2 diverse CHO cell lines, again expressing different molecules, were grown in 2 basal media formulations. Each cell line was passaged 4 times prior to the initiation of the GPA, and the growth performance assay was conducted in amber, again for 14 days, but in fed batch mode. Each feed panel was fed at 3% of initial working volume on days 3 through 13, along with the simple fed batch control condition, where glucose was fed up to 6 when levels fell below 3 grams per liter. And just to mention, the feed panel, similar to the basal, comes with, again, a protocol consultation, as well as support for data analysis. And the feed panel consists of 5 diverse ready-to-use feed formulations in 100 ml bottles. The heat map here displays the key component groups, which vary in concentration across the 5 different feeds. These 2 show relative fold improvement in titer over the simple fed batch control. For cell line 1, all conditions were grown in basal medium panel 6. For cell line 4, all conditions were grown in basal medium panel 4. And across the 2 cell lines, all feed panel formulations improved titer over the simple fed batch control. Relative to the 5 feeds, feed 2 had the highest titer, with feed 3 having the lowest for both cell lines. And this table shows day 14 full improvement in titer across the 2 cell lines with respect to the feed medium tested. again, the feed panels improved titer over the simple fed batch control, with feed 2 having the highest fold improvement in titer, which was up to 5.5-fold over the simple fed batch condition. In terms of viable cell density, you can see from the plot on the left, cell line 1, that all feeds improved growth over the simple fed batch condition. With the plot on the right, you see that cell line 4 responded differently to the feed panel, in which growth was similar or in some cases lower than the simple fed batch control. Now, as you recall from the previous slides, each of the feed panel formulations improved titer over the simple fed batch control, indicating increases in titer through an increase in specific productivity for cell line 4. In this feed evaluation, cultures were able to maintain high cell viabilities up to day 14 for all conditions, which is important to avoid potential process challenges. On day 14, cell line 1 conditions fed with GBS feeds 1, 2, and 4 were above 70% viability. Cell line 4 conditions fed with GBS feeds 1, 2, and 4, and 5 were also above 70% at harvest. So at this time, I'd like to just go through what we offer for analytics, and how you can use BioProduction Analytics to further optimize process. So we know that viable cell density, metabolites, titer, and all the outputs to your culture run give an indication of how the performance is in the health of the culture. But you can also use spent media analysis to have a deeper understanding of your process. And we do offer spent media analysis in which you can optimize your formulation using either amino acids or water-soluble vitamins, for example, and also look at the product quality. So one of the next steps for at the end of a panel evaluation could be performing spent media analysis to further optimize your media. And after seeing the results of the panel, a decision can be made to scale up into our GIBCO rapid prototyping facility or into our cGMP facility. So at this time, I'd like to hand it back to Stephen to introduce the next section of the presentation.
Thanks, Erika. I had a feeling I should pretend to be on mute there just to get you back for earlier. But I'll let you off. Never mind. Next time. So thanks very much for that presentation. Great to see some insight into those case studies. I did have a quick question for you, actually, that I noticed during your presentation. My eagle eyes noticed that the CHO basal media case study, there was only 8 media tested. Why wasn't it 9?
Yeah, so in this case, there was a constraint on the number of conditions that could be ran. This also, if this were to apply to a customer situation in which they are needing to reduce that number of test media, although we would strongly recommend testing all the media panel, either an R&D or field team member can suggest a reduced set of panel media based on historical results, but also ensuring a diverse formulation composition is tested.
Great, thanks very much. And if you want to ask Erika a question yourself, then you can, of course, do so. So please put any questions you have into the Q&A box and we'll answer them after the next presentation. Our final presentation is from our Senior Product Manager at Thermo Fisher Scientific, here to talk about manufacturing solutions for scaling up your panel media. Please welcome Megan Gorsica.
Great, thank you, Stephen. So Stephen mentioned we're going to talk a little bit about manufacturing and security of supply during my section. So, we've talked about the panel. we've talked through with Mara and we've talked through with Erika, the different benefits of the panel. We've touched upon our analytics. So the next piece of it that we're really going to talk about is, kind of small scale pilot manufacturing and how that can help you as you're continuing to work on your formulations and your process development work. And then, what to start to look for when you're looking to scale up into the GMP manufacturing. So what are the benefits of a small scale prototyping sort of facility? Well, the great thing about these facilities is they provide you with the opportunity, to order small volumes, typically get them delivered very quickly compared to GMP lead times. And also they give you the opportunity to test out things with your formulation. So you can test out multiple formulations. Maybe there's a formulation that you want to play around with some of the components of the different nutrients in there. And you can do that within a facility such as this, where you can get small volumes of those different formulations to be able to continue with your media screening work. Additionally, if there's some unique raw materials you want to add in, you can do that within these facilities. But more than anything, it really helps you to start to understand if the formulations you're working with are going to be manufacturable and they're going to be scalable. When we're thinking of the panels that we've been talking about throughout this session, those panels are all known to be manufacturable. They're all known to be scalable. So if you find one of those that does work for you, it is really easy to be able to move those through into the GMP manufacturing suite. So specifically within our PD Express offerings, we have our Gibco Rapid Prototyping Service that you heard Erika refer to. And this is our pilot manufacturing facility. And this is where, again, you can modify those formulations. Additionally, you can modify formats. If you're working with a liquid media format and maybe you want to change to a dry powder or, an advanced granulation technology format that we have available, this is a great place for you to be able to do that, test it out at small volumes, see how it's going to work within your process, and be able to then make the decision about how you want to be able to move forward. It's also a great place to be able to test out the raw materials and processes of a particular vendor. For us, we utilize our GMP raw materials and processes, so it gives you a good idea of what's to come, when you do go to scale up into GMP. We have fast turnaround. Typically from the time an order has been placed, you're looking at a 10 to 20 business day, turnaround time, depending on the complexity of the formulation and if there's any unique raw materials or packaging that we need to source for that. So it's a great opportunity for you to be able to get your foot in the door, to really start engaging with a vendor and understanding what their capabilities are. And with that, as you're looking to expand into your GMP manufacturing, there's a number of things that you should look for and consider as you're starting to have those conversations. And what I would say is first and foremost is this should be a partnership. This isn't just finding another vendor. This is finding a partner that you can work with, that's going to be able to help you identify solutions as you go forward and be able to meet your needs for the long term. So it's really important to be able to develop that relationship with that supplier, to be able to grow your business as you go. So when you're starting to have those conversations with the vendors, it's really important to understand their quality management system. Be sure to explore, their global logistics and distribution network to make sure that that's going to align with what your needs are specific to your business, and they're going to be able to get you what you need when you need it. And this also touches upon the capacity, right? You want to make sure that that vendor is going to have the ability to manufacture your media for you at the volumes that you need, but also that there's going to be some redundancy across manufacturing sites. You don't want a vendor who's only going to be able to manufacture at one facility, because if something happens at that facility, you then have nowhere else to go. So make sure that the vendors you're talking to, have redundancy across sites. So if something does happen, you are able to, still be able to have access to the media volumes that you need as you go forward. Something else that has become more and more important as we go forward is understanding raw materials. Understand how they're sourcing those materials. What kind of qualification do they do on those raw materials when they come in? Is there additional characterization work that's ongoing? And all of this is going to help you to understand and ensure that there's going to be lot-to-lot consistency for the media that is manufactured for you. So don't be afraid to have these conversations with the vendor. These are very important, conversations to have, and as you go to explore this partnership. From a GIBCO perspective, what you see here is basically represents our, media manufacturing network across the globe. And the goal here is that we have facilities that are strategically positioned, to be able to ensure that redundancy, to be able to ensure that we can provide the capacity that you, our customers, are going to need, and be able to provide that continuity of supply that is so important, as we're working within our cell culture space. So you see the different sites located around the globe to be able to meet your needs. And in addition to just the media manufacturing, you can see that we also have several pilot labs to be able to do that, as well as analytical capabilities at several places around the globe. So with that, hopefully this presentation was able to really give you a good feel for our overall PD Express services. With the media panel, we talked about the typing, and we touched upon some of our GMP manufacturing capabilities. So with that, I'll turn you back to Stephen, and we look forward to working with you to help you achieve your cell culture goals.
Thanks, Megan. Such an important topic to cover, especially at the minute. We have a quick poll we'd like to send you just now and for you to take part in before we move on to our Q&A then. This is a knowledge culture webinar. We also run knowledge culture seminars, which are more one-to-one based. And in a seminar, your company can select a number of topics that you're interested in, and we'll organise for a team of Thermo Fisher scientific experts to give you some of the latest insight on your chosen topics. So the question is, would you like us to get in touch to organise a free virtual seminar with you? And your choices are yes about single-use technologies, yes about downstream purification, yes about cell culture, yes about another topic, or maybe next time. So would you like us to get in touch to organise a free virtual seminar with you? Please select your answer just now. Is it yes about single-use technologies, yes about downstream purification, yes about cell culture, yes about another topic, or maybe next time? And also just a reminder that there will be a survey that pops up at the end of today's webinar. We're always really keen to get your feedback on what your thoughts are on our webinar, how we can improve, what other topics you'd like to see. So please do fill that in as well. So moving on to the Q&A then, we've had lots of questions coming in. We had some pre-submitted ones as well before the event even started. So lots to get through, and we've got about 13 minutes to do it. Let's see how far we can go. Megan, I'm going to come back to you straight away actually for this first question. It's from Paul, and he's asking, how can I get a media panel to test? That's a very good question.
That is a great question. So what I would recommend is reaching out to your, Thermo Fisher scientific cell culture rep. What they can do is then pull in the FAS or the field application scientist into the conversation, and they will be able to help you get connected with the media panel, get that shipped to you. But that field application scientist can also help you throughout the process. So they can help you, with the workflow, they can help you analyze your results, and they can help you really be able to determine what next steps make the most sense for you. So start with your Thermo Fisher rep, and then we'll get you connected with that field application scientist to really help you run the process.
Thanks, Megan. Okay, this is a question from Gareth. Maren, I think this one is for you. Why is it important to consider whether the cells are dependent on specialty components? From Gareth, Maren.
Right, that's also a good question. So our chemically defined media are designed to be as lean as possible, and they do not contain any of those specialty components. So when your current medium does contain them and your cells are dependent on them, I generally recommend to supplement them into our media as well, just at the same concentration, for two reasons. So firstly, this would make adaptation easier and provide a higher likelihood that a direct adaptation can be successful, since the cells would only need to adapt to the new formulations and are not weaned off the specialty components in parallel. And secondly, only if the current and also the new formulations do contain the specialty components, you can make a true and conclusive comparison of the performance.
Great, thanks. And moving on from that then, for yourself, Leonardo, here's a question from Susanna. She's asking, which CQA do you normally measure during media screening? And is there a general panel of assays that you recommend, or is it product dependent?
Well, yeah, that's a good question. And normally there are, it depends on the product for sure. But if we focus on MABs, for example, there is a panel of assays that you normally want to assess, like, I don't know, aggregation, the shed variance, or the titer for sure. The thing which is most important to me during the process development is that you have a good platform to make high throughput screening, especially when you're screening different media, different panels. So a good platform for high throughput screening will help evaluating also a bunch of CQA that will help you in the next step of process optimization.
Thanks, Leonardo. Hopefully that answers your question, Susanna. Here's a question from Emily, and Megan, if you could answer this one, that would be great. The question is the media made in GIBCO rapid prototyping GMP? And is there a limit to the volume of media that can be manufactured there?
Yeah, that's another great question. So the media that's made in GIBCO rapid prototyping is not GMP. However, we do utilize the same GMP materials that are used in our GMP manufacturing. But the facility itself is not a GMP facility, so that's why we don't make a GMP statement around that. The other thing that I'll just add too is, with your rapid prototyping offerings, not all of the same documentation is available. Keep in mind this is a pilot scale facility, so you're not going to get all of the, documentation and some of the other stuff that you would get from the GMP side. On the volume perspective, the volumes are smaller. You're looking at liquids up to 200 liters, powders, up to 10 kgs, and then AGT, we can go up to 8 kgs. So smaller volumes, but aligned with the nature of, the service.
Thanks, Megan. Erika, hopefully you're not on mute. I'll say that before I ask the question. We've got Puran here, and Puran's asking, is sequential adaptation typically required?
Okay, and hopefully you can hear me. Can you hear me?
We can hear you, yeah.
Stephen, I don't know if, okay, that's great. Okay, so yeah, sequential adaptation is not typically required. Customers that are already in chemically defined media, if they are not in a chemically defined medium and would like to be, for example, if their media has serum or hydrolysates, sequential adaptation may be necessary.
Lovely, thank you very much. Martin, let's come back to yourself for this one. I've got a double question here, and it's from Jade. Jade's asking, what about testing mixtures of the panel media formulations, and how much time will it take to evaluate the basal, medium, or feed panel? And that's another question that's been coming in as well quite a lot. How long does it take?
So to answer the first question, the panel has already been designed to be nutritionally diverse, so there is no need to mix or blend the formulations with one another. But well, if you want to increase diversity even further, you can do so by some design of experiments and mix them with another. For the second question, both the media panel and the feed panel do require to perform a growth performance assay, which is about 2 weeks. But before that, you would need to calculate some time for cell recovery after cell thaw, which is about 3 passages, so 1 week. And then for the media panel, you would also need to calculate time for the adaptation. This can vary from clone to clone, but as a rule of thumb, for direct adaptation, this would be about another week. So in total, 3 weeks for the feed panel and 4 weeks or a month for the media panel, from the cell thaw till the end of the growth performance assay.
Thanks, Martin. Megan, let's come to yourself for this one. This is a question from Louis, or Lewis, apologies, not quite sure how you're pronouncing it. Do you offer any other media development solutions other than panels? That's a good question.
Yes, we do. So, we talked quite extensively here about panels, as well as, we touched upon some of our analytics capabilities. But we do have the ability to do full media development and optimization projects, where we can actually bring in the cell line in-house, and our R&D teams will do the optimization work to be able to really develop, a media that's going to, achieve the goals that you have and be able to meet the nutritional needs of that. Additionally, we touched upon our analytics within, this talk, but we do have analytics that go beyond, just kind of your small molecule and large molecule testing, as we do have the ability to do stability studies on our, media that we manufacture, as well as, we can do investigative and troubleshooting analytics. So if you're having some trouble with your cell culture and you're not sure why, we can do that investigative and troubleshooting analytics to really be able to kind of dig down and try to understand, what's going on within that.
Great, thanks, Megan. I've got another double question here, Erika, and I think we'll come to you for this one. So this is from Sandra. Sandra's asking, which days should I collect samples for SMA, and what conditions are recommended for SMA?
Okay, yeah, so well, with conditions changing over time in culture, we would recommend having good coverage throughout the run, including the starting point of the growth performance assay, through the exponential growth phase and activity phase. So, for example, they could collect on days 0, 3, 5, 7, and possibly 10. For the conditions that are recommended for submitting to spent media analysis, if you're looking to optimize a medium, I would recommend selecting up to about 2 of the top performing media conditions and possibly a control media condition as well.
Brilliant. Thanks very much, Erika. And I think that's about all we've got time for today. We're nearly at the top of the hour. So I do hope you've taken something from today's webinar on cell culture optimization, manufacturing and security of supply. We've looked at the best practices in terms of optimizing your media. We had a bit of a deeper dive into some case studies and finally covered manufacturing solutions and security of supply. If you asked a question that we didn't manage to get to on today's webinar, don't worry, we will endeavour to answer all questions by email. And as I've said before, please do fill out the survey that will pop up when the webinar closes. Thank you very, very much for your time today. Stay safe and have a great rest of the day.